Hello, physical scientists at LeBois Junior High School. Here are a quick video set of notes on page 91 and 92 in your notebook on counting atoms. You're going to want to be taking notes on page 91 in your notebook. We're going to do some critical reading. I just kind of went ahead so you could see that a little bit. We're going to do some critical reading here. Again, this is on page 91 in your notebook. If at any point the video is going too fast, I encourage you to pause it and make sure you're getting caught up with what you need to. So this is a brief paragraph about the number of atoms in a compound. So the formula for a compound indicates the elements that make up the compound and the number of atoms each element present in the compound. We talked about that a little bit with our previous couple of pages, and this will add on to that and adding a couple other things where we're starting to include parentheses and things like that. So the number of atoms are indicated by the use of small numbers called subscripts. If there isn't a number there, it's an assumed one. If there is more than one, then there will be a subscript. That's, again, we talked about that on a couple of pages previous. Sometimes groups of atoms act as a single atom. Such a group is called a radical. So if a radical is used in a formula more than once, the radical is put in parentheses, and the subscript appears outside those parentheses. So when the subscript appears outside the parentheses, it tells us that all of the elements inside the parentheses should be multiplied by the subscript. Getting a little mathy here, so when we're talking about subscripts, anything on the outside of that parenthesis will apply to anything inside the parenthesis. Great example here is the formula FeOH3. So if we've got this formula right here, it indicates that we have one iron atom because there's no subscript right there, so there's only one iron atom. We have 3 oxygen atoms because that 3 will actually go to that oxygen. And we also have 3 hydrogen atoms because that 3 also goes to that hydrogen. All right, on to some practice. So in the following examples, it asks you to list each element in the compound and the number of atoms of each element present. So the first example has been done for you, and then I'll also do aspirin with you. So let's look here. So we've got calcium carbonate. You'll learn that CO3 is the carbonate atom, and we're going to start just getting you to recognize that as we go. So we have one calcium atom because there's no subscript 1 there, it's just an assumed one. So I want you to write Ca, and then I want you to spell out calcium, and then I'm going to ask you to put how many calcium atoms there are. And then you're going to go look here. So this is a C, this is carbon. So we're going to say there's one carbon atom. You're going to write the element, you're going to spell out the element name, and you're going to tell me how many there are. And then lastly, that O stands for our oxygen, and there's a subscript 3 there, and so there's only 3 oxygen. Notice there's no parentheses here, so that 3 is only applying to the oxygen right there, not to the carbon as well. Okay, a good example comes down here, and I'll do that one with you as well. So let's look at aspirin as our pain reliever. So first we're going to identify our element symbols. So we know that the C first is, we're going to say C is carbon. So we're going to write that down. And then our subscript tells us that there are 9 carbons there. So then I would indicate that number. Next, I know that H is hydrogen. So I'm going to write down H. I'm going to put hydrogen. And then I can look over here and say that subscript of 8 is there. So I know that there are 8 hydrogen atoms. And lastly here I have an O, and I see that by the subscript I have a 4 there, and so I know that there are 4 oxygen atoms. All right, let's move on to magnesium hydroxide. So magnesium hydroxide, you're going to start recognizing the names of these things that are a little bit unfamiliar. So magnesium hydroxide is actually found in milk of magnesia that's used for upset tummies. So Mg is our magnesium. And we know that there is one of them there because there is no subscript, so it's an assumed 1. So here we have our parentheses. So remember back from our paragraph that we read up above, our radical here, if there is more than one of them, there's going to be a parenthesis on the outside of it, and then the subscript will count for this whole radical itself. So O stands for oxygen, and oxygen, that 2 is going to go right there, and it's going to show that I have 2 oxygens. And then I'm going to look and see here that I have 2 hydrogens because that 2 is also going to count to that hydrogen. The rest of this page is going to be on your own. Do note that OH stands for hydroxide, and because the 2 is outside that OH, we would say that there's 2 hydroxides there as well. So you'll get good at identifying those radical names as we go through this unit. All right, the rest of this page, please, if you would do on your own, and then go ahead and check the key, that would be awesome. So that's the rest of page 91 there as practice. All right, this is also going to be practice here, and so when you're doing this section, you can go ahead and once you're looking at this, you can, after you've practiced that and tried to identify the atoms in the formula, you can go check the key. We'll have that linked. Here, what we want you to do is use the periodic table of elements to find the chemical symbols that match up the atomic numbers listed below. You're going to write the symbols in the space provided. In every instance, a symbol will be repeated in the chemical formula. Finally, write the chemical formula for each compound above the name of the compound. We've done the first one for you. So here we have atomic number of 25. When we use our periodic table, our atomic number of 25, my element symbol would be manganese. And so I'm going to pause right there, and then I'm going to go look and see if I have an atomic number of 8. I have 2 of them. So I say I have an atomic number of 8 there, so I have 1 oxygen there. Another atomic number of 8, so I have another oxygen here. So my chemical formula would be MnO2, and I put that little subscript 2 right there because I have 2 oxygens over here. This is a really important thing, and I would write this down. So in an ionic formula, the metal is always written first. And so that's why we see manganese dioxide written first here, not oxygen first in the formula. So sodium chloride, for example, sodium is our metal. That's why we always write that first. All right, so there's your example there. Go ahead and give it a shot. Again, use your atomic numbers to help you identify what you have here. You've also got some help with some of the names going on over here, and you can certainly work backwards. So the rest of this we would like for you to do on your own, and then go ahead and check the key as you're done. So the rest of page 92 is practice, and then check the key. Thanks for your hard work. Please email if you have any questions. Good job.